Okay, so today we are going to learn 5.6, okay, the last part of chapter 5, where the formula of sine A plus B or A minus B, cosine A plus minus B, tangent A plus minus B, sine 2A, cosine 2A, and tangent 2A. So today we are going to learn adding formula, okay, or compound formula. So sine A plus B is sine A cos B plus cos A sine B. So sine A minus B also the same. Only different one is the middle one, plus and minus. So I just think of sine is heterosexual and cosine is homosexual. Why cosine is homosexual? You see, cos and cos together, sine and sine together. But then at sine here is sine and cos together. Okay, so you see, cosine A plus B, so cos A cos B. If here is plus, then this one is minus. Then sine A sine B. Cos A minus B, so this one is cos A cos B. This one is minus, become plus, so sine A sine B. If tangent A plus B, it will be tangent A plus tangent B over 1 minus tangent A tangent B. Tangent A minus B is tangent A minus tangent B. And the one here is opposite, 1 plus tangent A tangent B. Okay? Next, let's see the double angle formula. So double angle formula is sine 2A is 2 sine A cos A. Cos 2A can be cos square A minus sine square A. Can also be 2 cos square A minus 1. Can also be 1 minus 2 sine square A. Okay. Tangent 2A can also be 2 tangent A over 1 minus tangent square A. Okay, you don't have to see the proof. You only have to memorize this. Okay, you only have to memorize this. So your half angle formula will be in this way. Okay, there's a rare chance you are using half angle formula, but it's the same as your double angle formula. It's just that we are going to divide the angle into half. Okay, so let's see. Simplify each of the following trigonometric function as a single trigonometric ratio. Okay, trigonometric ratio. So sine 20 cosine 50 plus cosine 20 sine 50. So this one is sine A cosine B plus cosine A sine B. So in the end, you become sine A plus B. So this one is actually sine 70 degree. Okay, how about this? Cosine 65 cosine 35 plus sine 65 sine 35. So this is a plus. So in the end, this one become minus. So cosine 65 minus 35 become cosine 30. Okay. Tangent. You see, tangent 30 plus tangent 10. 1 minus tangent 30 plus tangent 10. So this is a plus. So tangent 30 plus 10, so tangent 40. How about this? 2 sine 34 cosine 34. So it's actually sine 2A. So sine 2 times 34, so sine 68. Cosine square 42 minus sine square 42. So it's actually cosine 2A. So cosine 2 times 42, so cosine 84. 2 tangent 37 over 1 minus tangent square 37. So it's actually tangent 2A. Tangent 2 times 37, so tangent 74. Okay, so given that sine A equals to 3 over 5, sine B equals to 5 over 13, such that A is an acute angle, B is an obtuse angle. Without a calculator, find the value cosine A minus B. So first thing you need to know is you have to draw. So your sine A is 3 over 5, so cosine A is 4 over 5. Sine B is 5 over 13, cosine B is negative 12 over 13. So when you draw, you can find the sine and cosine. So cosine A minus B is cos A cos B plus sine A sine B. Okay, so cosine A is 4 over 5. You just substitute everything in. Then you finish the fraction. Then you have negative 33 over 65. Okay. Next, let's see. Given that sine P is equal to negative 3 over 5 and cosine Q is equal to 12 over 13, such that P and Q are angles in the third and fourth quadrants respectively. Without using a calculator, find the value of sine P plus Q. So in P plus Q, what do you need? You need one sine, you need one cos. Okay, sine and cos of different stuff. Okay, so remember, P and Q are in, P is in third, Q is in fourth. Okay, so let's see. If you have sine P, then you find cos P. You have cos Q, then you find sine Q. Okay, so sine P plus Q, then you have this way. Substitute everything in, then you get negative 16 over 65. So it's still counted as pretty easy. Okay, so find the value of A and of B that satisfy the simultaneous equation cosine A plus B equals to 1 over 3 and cosine A minus B equals to 5 over 6. Okay, with the condition A plus B is 0 to 90 degree, A minus B also 0 to 90 degree. So cosine A plus B, okay, you bring the cosine to the back, you get A plus B equals to 70.53. And A minus B, you get 33.56. You use calculator to calculate. And then A plus B, A minus B is a simultaneous equation. So we plus it together to A plus A, 2A, B minus B, 0. So 2A equals to 104.09, A equals to 552.045. Okay, then you substitute it back to number 1, then you get 50, B equals to 18.485. Okay. Given that sine A equals to 3 over 5, where A is an obtuse angle, A is an obtuse angle, okay, without using a calculator, find the value cosine 180 minus A, sine A minus 180, tangent 360 minus A. So first thing you need to find, cosine is 180 minus A. So 180 minus A is at second quadrant. Okay. So at second quadrant, sine A is 3 over 5, cosine A is negative 4 over 5, tangent A is negative 3 over 4. Okay, so cosine A, okay, cosine 180 minus A, then you put it in. 180 is negative 1. Okay, how do you know it's negative 1? You do the cosine graph. Then you can get, okay, cosine graph is from above coming down. Okay, so cosine 180 is negative 1, sine 180 is 0. So we end up with negative cosine A. So cosine A is this one. You put it in. So negative 4 over 5 become positive 4 over 5. Okay. Sine A minus 180. Also, you bring it up, become sine A cosine 180 minus cosine A sine 180. Okay. Cosine 180 is negative 1. Sine 180 is 0. Okay. Then I'm left with negative sine A. Okay, negative sine A will be negative 3 over 5. Okay, tangent 360 minus A. Okay, then I have tangent 360 minus tangent A over 1 plus tangent 360 tangent A. Okay, so tangent 360 is 0. Okay, so I'm left with negative tangent A over 1. So I have negative tangent A. So negative tangent A is 3 over 4. Okay, you substitute back everything here. Okay, here. It is given that cosine theta is 12 over 13, such that theta is an acute angle. Without using a calculator, find the value of sine theta over 2, cosine theta over 2, and tangent theta over 2. Okay, well, we use half angle formula. So cosine theta is 1 minus 2 sine squared over 2. So cosine theta is here, 12 over 13. Okay, so we bring 2 sine squared theta over 2 to the left, this to the right. Then we get 2 sine theta squared theta over 2 is equals to 1 over 13. Divide this 2 then it will become 1 over 26. Okay, this square, bring it back. Okay, square root 1 become 1. Square root 26 becomes square root 26. Okay, We don't have plus minus because sine is of an acute angle is positive. Okay. So using the half angle formula, we can also find cosine cosine theta over 2. So using cosine theta, okay, we can find 2 cosine squared theta over 2 minus 1. Then I'll be having 2 cosine squared theta over 2 equals to 25 over 13. Okay, and then after that, I'll be getting cosine squared theta over 2 equals to 25 over 26. Okay, the square, bring it behind. Okay, we ignore negative because cosine of an acute angle is positive. Okay, acute angle is 0 to 90 degrees, so everything is positive over there. So, and then in this triangle, okay, cosine is 12 over 13, but tangent will be 5 over 13. So tangent should be 5 over 12. Okay, tangent should be 5 over 12. This one is written wrong only. Okay, so using the half angle formula, tangent theta is equals to 2 tangent theta over 2 over 1 minus tangent square theta over 2. So become 5 over 12. Bring this to the side, and then this 12 cross multiplication. Okay, so 5 minus 5 tangent square theta over 2 times 24 tangent square tangent theta over 2. Bring here, you get a quadratic equation. Okay, then you have 5. Okay, let's say this one is x. 5x squared plus 24x minus 5. Then you get 5x minus 1, x plus 5. Okay, so you have 2 answers. So this one is an acute angle. So this we can ignore. Okay, we can just use this one to find 1 over 5. Okay. Okay, lastly is a proof question. So tangent x plus cotangent x equals to 2 cosec 2x. So from the left hand side, tangent plus cotangent, we bring it down. Sine over cos, cos over sine. Okay, make it the same denominator. Sine square x plus cosine square x, sine x cosine x. So this one become 1. Okay, if we multiply 2 to the numerator and the denominator, okay, we can get sine 2x below here. Sine 2x, okay, you bring it up, become cosec. So 2 cosec 2x. So this is your right hand side. Proven. Okay. LHS. B is sine 2y plus cosine 2y plus 1. Sine 2y minus cosine 2y plus 1. Okay. Same here. We use left hand side. So okay, so 2 sine y cosine y, 2 sine y cosine y, because this one is sine 2y. Okay, how about this cosine 2y and negative cosine 2y? So I can use 2 cosine 2 square y minus 1, and here I use 1 minus 2 sine square y. Why I use this one? Because you see, this one is cotangent y. Cotangent y is actually cos over sine. So I need to let the numerator have no sine, and you see, I don't want this numerator has cos, and I don't want this numerator have sine. I don't want denominator have cos, I don't want numerator have sine. So this one, the substitution of cosine 2y equals to 2 cosine square y minus 1, okay, can be eliminated. You see, if you open this bracket, minus 1 plus 1 becomes 0. This one also, negative 1 plus 1 becomes 0. Okay, so I'm left with this one. 2 sine y cosine y plus 2 cosine square y, and 2 sine y cosine y plus 2 sine square y. I bring the same out. I'm left with sine y plus cosine y and cosine y plus sine y. These two actually is the same. and this two number also the same. So I'm left with cosine y over sine y. So I'll be having cotangent y. So it's equal to my right hand side also. Proven. Okay. Prove the identity cosine A plus B over sine A cosine B equals to cotangent A minus tangent B. Okay, so from the left hand side, cosine A plus B is actually cos A cos B minus sine A sine B. Okay, you bring it, okay, to both sides. So your left side is cos A cos B over sine A cos B minus sine A sine B over sine A cos B. Both are the same numerator, denominator. Then you have to, okay, cross out the same one. Then you're left with cos A over sine A and sine B over cos B. Then cos A over sine A is cotangent, sine over cos is tangent. Okay, it becomes right hand side proven. Okay, then how about example 22? Sine over 1 minus cosine theta. Okay, cosine theta actually is 1 over 2 sine square theta over 2. And sine theta is actually 2 sine theta over 2 cosine theta over 2. Okay, then you bring it out, 1 minus 1, 0. You're left with this one. So 2 and 2 normal. Okay, and then you have 1 sine over here, you have 2 sine over here. So I'm left with 1 cos and 1 sine at the below. So cos over sine is actually cotangent, so right hand side proven. Okay, find all the angle that satisfy the equation sine theta cosine theta equals to 1 over 8 for 0 to 360. Okay, sine theta cosine theta is actually 1 over 8. Bring the 8 to this side. Okay, and then you let 2 become the one inside. Okay, so what do you have here? You have 2 sine theta cosine theta. Okay, then 2 sine theta cosine theta is sine 2 theta. Then I'm left with only 1. Just now I have sine and cos, so it's hard for me to find. But I only want one trigonometric ratio over here. So now I'm left with sine 2 theta equals to 1. So sine 2 theta equals to 1 over 4. Okay, so 2 theta is all these angles. So theta is all this angle. Okay. Find all the angles that satisfy the equation. Okay, this one is easy. Okay, you have cos, you have sine. So we just change the cos to sine. Okay, so that the whole equation becomes sine. If the whole equation becomes sine, you'll find out that you get a quadratic equation over here. 10 sine square x minus 9 sine x plus 2 equals to 0. So this one is 10x squared minus 9x plus 2. Okay, so you do your quadratic equation. Okay, so your sine x equals to 1 over 2 equals to 0.5. So, and then also equals to 0.4. So if you find 2 answers, then you have to do 2 answers out. Okay, remember. Okay, this one is also the same. Okay, find all the angle that satisfy the equation. 2 sine theta plus 45 equals to cosine theta plus 45 for 0. Okay, 0 to theta to 360. Okay, so sine theta plus 45 is actually 2 sine theta cosine 45 plus cosine theta sine 45. And at the back here, cosine theta plus 45 is actually cos theta cos 45 minus sine theta sine 45. Okay, then cos 45 you can get 1 over square root 2. Okay, sine 45 also. So you have this. Okay, then we have to factorize 1 over square root 2 out. Then you have this one. Here got 1 over square root 2, here got 1 over square root 2. We can, okay, eliminate it out. So we're left with 2 sine theta plus cosine theta equals to cosine theta minus sine theta. So I have 2 sine theta, 2 cosine theta. Over here got 1 cosine theta, and 1 sin theta, negative 1 sin theta. So I bring here, I will have 3 sin theta, and I have 1 cosine theta. Okay. Bring it here, and then I'll have sin theta over cosine theta equals to negative 1 over 3. Then sine over cos is tangent. So tangent equals to negative 1 over 3 become negative 0.3333. So my basic angle is 18.43 degree. So my angle will be 161.57 degree and 341.57 degree. Okay. So this is the homework. Okay, you may print screen, and also you may pause this and then do it. Okay, so this is one. This is another one.